Good afternoon and welcome to today's webinar, which is titled Leveraging IT Infrastructure to Build a Smarter Business. This webinar is brought to you by Express Computer in partnership with IBM. I am Mohit Rathod, Senior Correspondent with Express Computer. You know, unexpected disruptions teach us to bring our talents and technologies together in order to find a faster route to innovation and the future. And this is a lesson which is well demonstrated by the recent events. It has taught us how essential IT is to keep businesses running and why we must design architectures for tomorrow. For one reason, it helps us build a resilient and smarter business that can act at speed with insight to navigate the unexpected and drive digital transformation in the toughest times. Digital transformation is majorly being driven by data, AI, and cloud. But the new digital imperative dictates that we build a smarter business by extracting more from our digital transformation initiatives. Understanding the criticality of digital in the current landscape, this webinar will explain the power and immense potential of digital initiatives. So today we are joined by industry speakers, Prosenjit Biswas, lead architect, Red Hat, India and South Asia. Prosenjit focuses on increasing business value and enabling digital experience to Red Hat customers. With over 20 years of experience in the IT space, he bridges the gap between technology and business through transformation, automation, and integration that unlocks true business value. Prosenjit leads the composite teams of architects and engineers pursuing solutions to clients' needs. We are also joined by Mr. Siddhis Nayak, who is country leader, storage and software-defined infrastructure solutions, IBM India and South Asia. Siddhis has more than 20 years of experience in the information technology marketplace with an extensive background in sales, operations, and brand management. He has been with the IBM company for over 18 years now in various roles in sales and brand management. But before we take the session forward, I will read out some of the information regarding this webinar. This is an audio and video webinar which is being broadcasted live and it will be available as on demand. We will have a round of Q&A at the end of the webinar. However, you can send in your questions at any time during the webinar using the Q&A text box. If you face any technical issues, please reach out to our team using the same Q&A box and we will sort the issue to the best of our abilities. If you have any further questions or if you wish to interact with the speakers, please leave a comment using the questions box and the IBM team will contact you post the webinar. So that's all from my side now. Without taking much of your time, I invite Siddesh to take the session forward.
Thank you, Mohit. Let me share my screen. Good afternoon and very, very warm welcome to all of you. Hope all of you are doing good and are safe and healthy. Thank you for joining us this afternoon. Today's webinar is about infrastructure for a smarter business, a platform for a smarter business. And who better than IBM and Red Hat to come together and bring together the expertise where it matters the most. IBM, both IBM and Red Hat don't need an introduction, but just to put things into perspective, IBM is a 100-year-old company, #1 on AI, #1 on data sciences, #1 on multiple security segments, #1 on data center services, hybrid infrastructure services, security and DI. And Red Hat, of course, is a 25-year-old company, #1 on open source solutions, #1 on all the app modernization and the container platforms, #1 contributor to Linux, and of course, #2 contributor from a Kubernetes perspective. So together, these giants are bringing in expertise where it matters the most. Together, they are setting the stage for the new hybrid multi-cloud and the app modernization era. Now, over the past 1.5 years, what all of us have seen is one thing that the pandemic has brought in is it has accelerated the pace of digital transformation. And if I look through some of our top clients and try and analyze what have been the transformation levers for this digital transformation for clients, there would be three broad areas that come out. The first one being journey to hybrid multi-cloud. The whole journey to app modernization, movement to cloud native environments, ability to have multiple cloud environments, be it private cloud, be it public cloud, and all of that working together in a seamless manner. The second transformation lever is about adoption of AI and bringing it mainstream. In fact, IDC has gone and predicted by 2023, more than 50% of the applications are going to be AI enabled. And third, which is last but not the least, is there will be elements that continue on premise. How do I modernize and transform these workloads that continue to remain on premise? How do I make them more resilient? How do I make them more performant? And at the same time, how do I make them seamlessly operate with this hybrid multi-cloud environment that we going to create? Now let's look at each of these levers, and we will look at how IBM is trying to address each of these transformation levers and how Red Hat is trying to embrace these levers for the same set of clients. Let's start with the first lever, which is the hybrid multi-cloud. The hybrid multi-cloud is pushing clients to get into a data-driven multi-cloud architecture. It is so if you look at the scenario today, most enterprise clients have a presence across multiple public clouds. They have Amazon for maybe certain risk modeling services. The HR module is better on, let's say, Azure, so they're out there on Azure. There is some other module that works good on IBM, so it's in there. So there are a minimum of 3 public cloud scenarios that most enterprises are seeing today. At the same time, they have a private cloud that they've set up, and they have elements of on-premise infrastructure that also continues. Now, how does all of this seamlessly work together? In fact, the direction we see clients getting onto is how does my on-premise become a fulcrum of these multiple public cloud environments that I'm working with? How do I have a single pane of glass across each of these is what the direction is all about. And the underlying architecture needs to be flexible. It needs to permit data portability across private and public clouds. Of course, it needs to be secure and compliant. It needs to have a high ROI that can be applied across multiple set of use cases. It needs to be service level driven, software defined, something that can be automated using APIs and also has a self-service capability. It needs to be certified across all the popular platforms like Kubernetes plugins like CSI, and of course the OpenShift container platform. That is something that is becoming the baseline for the multi-cloud architecture that clients are embracing. Now, what is IBM doing to help clients embrace some of this? Now, as clients get on to a public cloud environment, what IBM has done, and we went and announced this in early 2020. This is an offering called Spectrum Virtualize for public cloud.
Sorry to interrupt, Siddesh. Your voice is it's not constant. There's some fluctuation.
Okay, is it better now?
Yeah, now it's better. Thanks.
Okay, thank you. So Spectrum Virtualize is for public cloud is something that IBM announced in 2020, and this Spectrum Virtualize is basically the engine that powers all the storage flash portfolio that IBM runs across the board, right from some of the largest banks in the country to some of the large SAP installs, some of the largest payment gateways, practically most of the mission critical environments in the country. Now, what IBM has gone and done is this software is available as a bring your own license on some of the top cloud providers. We have it available on IBM Cloud. We have it available on AWS. We have it on Azure as a beta now. We will soon have a production version available. And in the near future, we will have it on Google Cloud as well. Now, what this does is it allows you a seamless connectivity with your on-premise environment. Uh, so for example, we just did it for a large insurance company just last week. They wanted a transparent cloud tiering. They're running their risk modeling on AWS, and they wanted to take a daily production snapshot after they do the anonymization of the data. They wanted to take a snapshot onto S3 of AWS on a daily basis. Something called as transparent cloud tiering. This gives you an ability to do that. The other piece is, if I want to run a DR on the cloud, I have the ability to run a replication relationship between on-premise and the public cloud and run a seamless business continuity on the public cloud. Not just that, one of the major use cases that we've seen clients embrace is an ability to bring enterprise data services on the public cloud. Now, what do I mean by enterprise data services is when you actually look at a storage on-premise, you look at enterprise data services like you over provision it. You have thin provisioning with auto detect. You have compression. You have deduplication. You have clustering to give you high performance. You have tiering that you do to give you low latency solutions. Now, all of these aspects, practically none of the public cloud providers give you these enterprise data services. Spectrum Virtualize for public cloud gets you these enterprise data services. And at the same time, the data reduction pools of Spectrum Virtualize help you even save on your monthly billing on AWS or on any other public cloud. Now that really brings in efficiency both from a technical perspective as well as your monthly commercial outflow as well. Again, an example where we did this for a client just a few weeks back. We were able to bring down their EBS workload on AWS. EBS is Elastic Block Storage. We were able to bring down their EBS workload on AWS down from 20 terabytes to 8 terabytes, which means their monthly billing is going to go down significantly. We've done a clustering across 4 EC2 instances, which gives them the performance they want, gives them the availability that they want. At the same time, they're able to keep their monthly bills to the optimal level. So that's the piece of work we're driving with clients. Of course, we've also launched something called as Spectrum Suite for container environment, Spectrum Suite for cloud packs. What this really does is it gives you a complete enterprise capabilities. As more and more customers embrace these environments for production workloads, you need data services which are enterprise ready. You need data protection for your container platform. You need a very simplistic way to deploy this. So what the storage suite does is it gives you a flexibility to deploy any of these aspects that you see on the slide, be it an object storage, be it a Spectrum scale-based file storage or a block storage. You could deploy it on the public cloud. You could deploy it with the OCS storage or with Red Hat Ceph storage. You have the flexibility depending on the environment that you have. The licensing gives you the flexibility to go and deploy as and what you need. You could leverage existing infrastructure with automation through CSI and Ansible. You could share infrastructure and data with existing platforms. And all of this is, of course, certified and tested for Kubernetes and Red Hat OpenShift. With that, let me hand over to Prasanjit to hear Red Hat's perspective on the hybrid multi-cloud transformation. Prasanjit, over to you.
Jitesh, thanks. I think great analogy you have made. What I can understand is that something short of scale and optimize with Spectrum Virtualize as the storage suite, and then thereby give availability and security all together. But a very important point that you brought in, that 100 years versus 25 years story of both the company existing, or 100 plus and 25 plus. I will just say or start with that within this 25 plus, why people saw us as most relevant and why relevant kind of story comes in. The first thing is that we definitely follow an open source model, where the development we interact with community and then we interact with projects, and thereby we keep it to the enterprise product, or we convert it to enterprise products and deliver it. What does it bring? It brings complete innovation at the enterprise level, and thereby providing an technology assurance and expertise from Red Hat side to the enterprise customers, be it on on-premises or in any public cloud or in hybrid model that we are talking in mostly at this juncture. And then what relevance we bring in from customer side, if we see, so we do IT optimization, where we do transform the existing IT landscape that customer is running on. We definitely embark on hybrid cloud infrastructure, where the customer can scale their application as required in any of the layer that they want, be it on any cloud or private, or being combination of both. Definitely, Red Hat brings cloud native development model, which is very important for customer nowadays, because most of the applications are getting transformed to cloud native architecture. The more and more cloud is getting relevance with, say, a private landscape, you will see more and more customers are embarking onto that journey. One more important thing, definitely, with all saying everything is running in different application sets or different container form, I will say, integration is definitely a big subject altogether to integrate different applications, how the storage will integrate with software set, how network will integrate, and then how application will integrate in between. So Red Hat is on part of integration layer. Being all these complete thing, I think automation is the obvious thing that we want. We don't want to do things repeatedly as in older fashion we used to do. So Red Hat brings automation as a journey. Now, the why Red Hat portion and then what relevance, it all starts with tried, tested, and trusted mechanism. I can only say that 100% of commercial bank of Fortune 500 runs with Red Hat, 100% airlines runs Fortune 500 runs with Red Hat, and 100% communication service provider, be it means Airtel, Vodafone, or anyone that we say, or global Fortune 500 companies runs on Red Hat. Yeah, Shideshik, you can go to next slide. Okay. Now, if you see that hybrid multi-cloud platform with IBM, what we are trying to wonder on the customer base. See, at first, there is some infrastructure layer. Now, the infrastructure we used to see as only private or say physical and virtual layer is getting extended to cloud layer. Now, on cloud is also in multi-cloud layer that we are seeing. And the context is that we need to run as is in every environment as much as possible, so that customer can use their own knowledge base or single knowledge base or single source of truth for any of the environment in a seamless fashion. Okay. Now, to bring this up, you definitely need an probably a common kind of capacity built where the platform will get in. Where IBM storage team is helping with Spectrum Virtualize, or say Cloud Pack for storage, where multiple mechanisms can be deployed on different infrastructure layer, but in a cohesive manner. Thereby, the foundation of Red Hat starts in. It basically starts with Red Hat Enterprise Linux. So Red Hat as an organization was known for Linux and still known for Linux itself. Then we embarked on OpenShift container platform, and container is becoming more and more obvious journey. People first landed onto physical layer with Unix, and then they converted to open platform like Linux, which is Red Hat Enterprise Linux. And thereafter, they try to see that what, transformation they can bring with virtualization, and then shifted to, or slowly getting shifted to containerization as much as possible, because that gives a nimbleness and deployability mechanism in uniform deployability mechanism in any of the layer. And thereby, running a platform doesn't suffice. You need application services or middleware layers, which again Red Hat brings in, and thereby automation platform as Ansible automation platform. To bring on Ansible story, it is probably highest downloadable community product that exists in this world. So this is one of the platforms that people uses most. Being said that it is not an application automation, it is a task automation and IT infrastructure side. However, Red Hat keeps a process automation also, which is an application automation side from a middleware standpoint. And then deployable in all these containerization layer, how will you deploy and manage in multiple layer of cloud? We have, and then maintain the security in uniformly, is that we brought up a product called RHACM, Red Hat Advanced Cluster Manager, and then RHACS, which was earlier StackDocs, and now all these application container services, security services. And then thereby you see enterprise architecture built in and customer builds in capabilities like say applications, data subsets, integration, automation, multi-cloud usability, all these. Okay. However, bringing on those workloads, we can't ignore partners because partners is very say third pillar of our success. We see, and then we say partner with say kind of TCS, Wipro, Infosys, or say in tier 2 partners with even with IBM GPS, IBM systems to build an development model to create a data scientist, empower data scientists as much as possible in AI layer, and bring up those architectures that how do I connect all my app kind of story, and then line of businesses, how they are doing, how do I remove friction between or speed between time to market kind of situation and operations altogether. Means how seamlessly we can bring operational efficiencies into the customer space. Yes, it is. I think you can go to next slide. Okay, it's yours.
Thanks, Prasanjit. I think very beautifully. The core aspect, as you heard, Prasanjit, both these transformation levers together, IBM and Red Hat, are able to weave in and help customer embrace some of the critical elements of these transformation levers. With that, let me move on to the next transformation lever, which is the core transformation. Now, as I said, there are elements of the core that continue to run on the core. Of course, there are some of the smaller enterprises that would want to move the entire piece onto the public cloud, but there are most of the large enterprises who would want a mix of public cloud and private cloud and create a hybrid multi-cloud story. And in those scenarios, how do I really build and transform the aspect or the elements that stay back on core? How do I make it a lot more performant? Now, if one of the elements of performance that we've been driving with our clients is around our Flash story. Way back in 2012, IBM acquired a company called Texas Memory and started developing something called as a Flash core module. Now, a Flash core module is very different from a standard SSD, a traditional read-intensive SSD that the entire industry drives. What a Flash core module brings in is an ability to bring in not just performance. So one of the aspects is it comes in with a built-in FPGA that powers the compression and encryption within the Flash core module. So you don't really have to depend on the controller, the storage controller, to run your compression and encryption for you. The entire workload of that is taken by the Flash core module by itself. So that is one aspect. The second aspect of the performant aspect is IOPS, which are absolutely unprecedented, throughput levels, which are absolutely unprecedented. We're talking about latency levels, which are sub 200, 250 microseconds. And this is by and large the highest you would see in this industry. Much higher than the most read-intensive deployments that you see from all other competitors. The next element is around endurance. Now, when you talk about these environments being deployed for mission critical environments, what you really want is you want an endurance level which is significantly high. Now, what the Flash core module does is it does something called as a variable stripe RAID, and it does a two-dimensional RAID, which means I have a Flash core module. I have some form of RAID that is within that Flash core module. Let's say a Flash core module has 16 DIMMs. I have some form of RAID that is built in within these Flash core modules, and I do a distributed RAID 6 across the Flash core modules as well. Now, what this net of it means is I am bringing in endurance, which is almost 4 times that of a read-intensive drive, and that is where if that is what has really clicked with clients for us over the last 1.5-2 years, we have seen a lot more competitive clients embrace our Flash core story, surely because of the performance and the endurance story that we bring onto the table. Moving on, just to give you a glimpse of our Flash portfolio, starting from an entry 5015 to a 9200, which is one of the most performant boxes in the industry at this point in time. We have the entire range, all right from 5035, it's all NVMe certified. One of the differentiating factors that we've been able to bring onto the table has been around hyperswap. Now, some of our largest banking customers or telecom customers, what we've done is we have moved their top 8 or 6 applications onto a hyperswap. Now, hyperswap is like a high availability solution between storage boxes, and it's an auto failover onto the other storage box. So what it ensures is if you have a absolutely top of the end mission critical application, then you need high availability of the highest level. This is what it gives you, and it's an automated high availability. We've in fact deployed it for some of the very large banks as well, where the transactions per second are extremely high level. With an Oracle database underneath, we are able to fail over from one storage box to the other without even the database failing. It's a seamless failover from one storage box to the other. So a variety of solutions available around this, right from an entry level to the highest end 9200R, and we'll be more than keen to talk to you on any of your requirements that come up. One of the aspects that has become very, very popular these days is the 3-site solutions, where you want high availability levels, you want a 0 RPO and a 10-minute RTO kind of a solution, and that is what we've been deploying across multiple clients. And of course, last but not the least, your new age workloads, which are your container workloads, your application modernization. How do you have a storage environment that is very, very tightly coupled? So let me give you an example of a telecom giant who runs his entire DevOps environment on a container environment. And we have a tightly coupled storage environment, so that when I spin off a container, I have a tightly coupled storage environment that is spun off, and it's dynamically coupled. Of course, when I collapse the container, the storage is a persistent environment. It is a CSI interconnect that tightly couples these two, certified for OpenShift and CSI, gives the client very, very seamless ability to deploy it on a container environment and also have it as a persistent storage that the remaining teams and newer containers can continue to use. So one more element of the core transformation is about backup. Now, one of the aspects of backup is we've always been on the enterprise side of backup with Spectrum Protect. It's been there for decades, long, rich enterprise proven history. It scales up to petabytes and petabytes of data. It is cyber resilient. We've also introduced something called as ransomware detection, where it actually monitors the activity at the back end, and any anomaly is detected as a possible ransomware alert, which they expect the customer to go check so that we are secure. But not just that, we've started moving on for backup to scenarios where it is much more than backup. It's not just for the traditional apps and hypervisors. It now is moving to backup for containers, IaaS, PaaS, SaaS. It is also becoming important. In fact, few of the conversations that we are having with clients, clients are talking more about secondary use cases than the traditional backup and recovery. Traditional backup and recovery is a given. How do I have a backup for VMs in a native format that can be redeployed for multiple reuse cases? That is what is becoming the conversation. So multiple elements that is expanding the scope of the modern data protection element as well. With that, let me move it back to Prasanjit to hear Prasanjit's perspective, to your Red Hat's perspective on the core transfer.
Yeah, okay. So Sitish, thanks. I think unlike the product set or the storage J's that you have, I think in the core layer, we have two main products. One is Red Hat Enterprise Linux. As an organization, we are known for Linux, definitely. Okay. And then just to enhance it, that Red Hat Enterprise Linux almost carries in paid Linux market from 65 to 70% altogether, which is very huge as in altogether Linux as an ecosystem. And it is only paid Linux, I'm saying, then our contributions are community. So it's an established product in the organization. Many people use it for any purpose. And then the same Red Hat Enterprise Linux in seamless fashion can be deployed in any of the environment customers want. However, only Linux doesn't suffice as many of the customer requirements, because unlike in storage, availability is built in, we also need it in application layer this availability. So high availability is part of Red Hat Enterprise Linux that can be taken into consideration as a separate product. And then it's again, when customer deploys Linux, it actually nowadays is happening that how they will analyze their application, how they will analyze their failure concerns, or can customer get an information that where the bottleneck is going to be, is something short of AI driven analysis customer are looking for. And then Red Hat has embarked on a product called Red Hat Insight, which gives an actionable insights before the failure happens kind of situation. And then definitely deploying all Linux environment, you need a complete life cycle where you will put iterators, bug fixes, or updates the products. And all these three things combined with, you definitely need a 24 by kind of support from an organization who backs it all 24/7 for your organization, for your critical applications to be running. And not only that, you need some sort of update support also in a minor or major versions that also Red Hat brings in within Linux. Yeah, Siddesh, if you want to go to next. Okay, now continuing with Linux portfolio, we came up with an OpenShift container platform. Rather, I will say that we started the Kubernetes journey by 2013 and 14, and then thereby 15 onwards, bolster products will come. It's very early, we say, except Google is the inventor of Kubernetes, but secondly, Red Hat has started inventing, and that's why we are number 2 contributor on Kubernetes layer. However, we started very early when people didn't thought of that a container can be an obvious thing will come in for hybrid cloud layer. We started that journey at that time. Okay, but we built our base very strong. We started with same Red Hat Enterprise Linux, and then we acquired one company called CoreOS, whose artifacts layer we engaged with our Red Hat Enterprise Linux and created the base. And thereby that Kubernetes is an orchestration, and Kubernetes as in cluster services for over-the-air upgrade, networking, English storage, all these monitoring layer, and then registry authorization, all these we bought it. Thereby, on top of that, we bought a concept that how customer will manage workloads. So that means thereby you need an platform services, which comprises of maybe service mesh, serverless architecture, CI/CD, all buzzwords that you heard in. It's actually in productized version available from Red Hat. And then GitOps kind of situation, log management, cost management, all these factors as a manage workload concept point of view we have came in. And then not only that, how we thought of that, how customer or say organization will build in their applications or develop their applications. So there's some developer code bases are required for cloud native architecture to be converted on. So thereby we included as language and runtimes, and then API management, uniform integration layer, messaging bus, and then process automation kind of situation. And to give a data-driven insight, like say data services, databases, caches, or data ingestion preparation kind of situation, kind of data management and resilience layer also to be built in. And definitely all these products are developer-centric products, so developer need to be empowered. So we created a developer-centric product called code-ready workspaces, where all developer can come in and develop their applications on a cloud-native architectural point. Here the journey actually is complete landscape. However, that need to be scaled to in different environment, right? Be it physical, be it cloud layer, or be it hybrid modality. And that's how that multi-cluster manageability, cluster security, and global registry kind of situation came in. So there are 3 distinct important products, which again can attach to OpenShift as a platform. Is advanced cluster management for Kubernetes, which can manage uniform way, or say which can do observability, discovery, and policy, and then configuration and workloads in across clouds in seamless fashion. And then advanced cluster security, you need probably declarative security and then runtime security for containers, or threat detection and response, online threat detection and response kind of situation, which gives in. And the third product is QA, which is global registry, that how do you manage a single source of truth by deploying in multiple environments. So that's the registry bring in. It creates a complete gamut plus, we call it as OpenShift Plus, But yes, it can be taken individually also if OpenShift is already deployed with all these components, or customer can start with OpenShift and then thereby scale to these products or these solution sets. Yeah, Siddesh.
Hey, thanks, Prasenjit. I think the story beautifully weaves in together as customers embark on the infrastructure layer, and then the building on top of the infrastructure layer, the foundation layers or the platform layers from a Red Hat perspective. Now, with that, let me move on to the third lever, which is AI for business outcomes. And here I'm going to lead with three examples of how I see clients embracing AI for production environments. The first example is about a check validation story. Check truncation has been around for a couple of years, I think 6-7 years now. Now, what happens is there is an MPCI repository where the check image comes in. There is an MICR code, and then the check image is actually looked at by the validation team in the bank. They key in the details into the core banking. They do a date validation check. They do a check on between amount in words and figures. There is no overwriting. There is no. There was a court ruling which said that you can't have two inks in a check. Of course, the signature validation, account payee and bearer, all of these elements have now been put on to a deep learning model. Two deep learning models. One is TensorFlow, which takes care of most of the aspects, except the signature validation, which is done by a deep learning model, which is on PyTorch. Now, these are open source deep learning models, which have been deployed for the check validation. And a large bank in the country used to have about 20 people who used to do this for them. They have now automated this entire process, and all of these people have been redeployed into something else. The only time when validation happens back again is when the accuracy level is below the threshold defined. This is a classic example of how AI is being used for. There are two approaches that clients are doing from an AI perspective. Use it for better customer experience, or use it for operational efficiency. So this is an example of operational efficiency. Let me go to an example of how client is using it for customer experience. Now, this is a general insurance company that's deployed an AI solution for vehicle damage assessment. I can take a picture on my mobile phone of the damaged part. So let's say it's a Honda City, left rear fender of the Honda City. When I take an image, I'm able to gauge the part as it appears in the parts catalog of that insurance company. Get the associated part cost, associated labor cost. You first go and categorize the damage into multiple categories. The smaller categories can be repaired. The higher damage ones parts have to be replaced. Within a fraction of a minute, the model has an ability to go through estimate for the damage. And what the general insurance company has done is a scenario where damages or claims which are less than a certain threshold, they want to settle it then and there. The customer can go get it repaired in any workshop nearest to his house. He doesn't need to go through a surveyor and assessor. This is another example of how clients are embracing AI. Let me get on to a third example, which is more around data warehousing, more around analytics. This is a telecom giant which ingest call data records for 400 million subscribers. And when you talk of 400 million subscribers, you are talking of a scale which is unprecedented. You're talking of ingest, which is unprecedented. You're almost talking of a petabyte of data per day. It all gets converted into a Parquet format. This becomes the baseline for all the analytics they run, right from their call drops to their campaign management to their new network deployments. The works, all of the analytics really runs on this platform. So That is what we are driving with various offerings in the AI space, be it Spectrum Scale, which is one of the most popular high performance stories that we have. It brings in a single namespace. It brings in a capability to bring global collaboration. It is a multi-protocol scenario where you can run it using POSIX, you can run it using NFS, you have block storage capability, you have a file storage capability. Uh, you use it for workloads which are like Spark ML, you use it for Splunk. One of the popular use cases that we've started driving with Spectrum Scale has been around a shared storage architecture for Cloudera. Now, as you get into a Cloudera scenario with a shared nothing architecture, which is basically x86 servers with which are storage rich, as against that Spectrum Scale based shared storage architecture, you are able to see a lot of benefits. In terms of no multiple copies of data. Your ingest timelines are significantly better. Your performances to the next level, your ability to do high availability, your ability to do backup, DR, all the enterprise services that you would typically need in a enterprise scenario is what you're building in. Of course, you have products like Discovery, which help you do metadata tagging, do help you with the cleansing and the tagging aspect of data. And you have object stores, which is used for large scale archival. And Spectrum Archive, which allows you a tiering across multiple tiers. It could be a tiering across Flash, NLSAS, and the cloud layer or the tape layer. We do this for some of the smart city deployments across the country, where we use the videos, surveillance videos are stored on the Flash tier only for 6 days or 7 days. It then moves on to the tape tier. But what you have is a Spectrum Scale layer on top of it. Spectrum Scale layer ensures that when the video management server raises a query, irrespective of whether that video is sitting on the Flash tier or the tape tier, the VMS is able to see it in the same fashion, and you put a setting which a policy which allows you to retrieve that particular file as soon as there is a query that comes in. So this is something that we've started deploying across smart cities, some of the airports, and has become a very popular lifecycle management kind of a tool. Let's hear Prasanjit on how is he tackling the AI transformation lever. Prasanjit, over to you.
Yeah, Siddesh, thanks. I think you well defined that ingest, organize, and analyze kind of situation, and thereby the drive it to the correct tier of the storage where it matters most. Okay, but I will just say that on AI ML architecture, many people have a myth that it is very complex, and then delivering or building that platform itself is very tough. It's not actually, or rather, I will say that we definitely need data scientist expertise, but the building it for them is not so as it is complex we thought of. Now, if you see in traditional model, there is a feature request comes in, and then architectural design goes on, and thereby people develop it, and then test, UAT, production, and monitoring. This is the traditional life cycle of the application anywhere from the asked while you go from the beginning itself, it's going on, right? And then thereby some qualification, DevOps, and all these cultures are coming in. However, in data science model or data scientist arena, if you see the same model or modality is been converting, like say feature request is being treated as codifying the problem and matrices. Architectural design is data collection and cleansing or cleaning, and then develop is becoming feature engineering. Test is becoming something model training and tuning, and then UAT is model validation, and production may be model deployment, and finally validate the complete thing. And thereby, if you just click that, I think the next iterative fashion comes in, that it goes in, and then thereby more and more validations comes in, and the code base is or model been validated and qualifies so that it can use it for the purpose it need to be. Yeah, please go to see this next slide. And it's not very complex, because we just need to focus in two definite areas. One is right from getting started and getting into production. But if you see that more the capabilities now, it is almost same. Like say both require self-service capabilities, repeatable, shareable environment, ease of instrumentation, so that I don't need to bought it every time a new version that is required, repeatable and shareable experiments so that it can go back and forth kind of, and access to specialty resources like the GPU, where the data harnessing or the compute harnessing can be possible. And the biggest and most to go in getting in production, you need and scale out. Now here the situation comes in, because if you are doing in some layer of say or some cloud, and then you are seeing that there's a bottleneck, you should be able to scale out in others. Okay, yeah, so this put next slide. And then I say it as a container for models. Why it is? Because it's a simple, lighter and denser than VM. So it's very lightweight. Containers are very lightweight. And then base image guaranteeing starting consistency. That means you can deploy in any of the platform, any of the layer where OpenShift is deployed. You can deploy in same fashion that you want. And then package apps with all dependencies. You can build it in package kind of thing. We understand that containers are very packageable and can be treated as an universal base image kind of situation where it can be deployed with all dependencies all together, and reusable, portable, and shareable as an unit. Okay, and then thereby serving the reproducible and shareable environment for building, training, and serving the model. Okay, and then thereafter you can use this Python, Jupyter, NumPy, Pandas, MultiCloud, and then create a model. So these software sets are enabler, but how you need to create a process where these software sets can be used those process and build that model. Yes, Siddesh, please next slide. While doing that, AI, Red Hat as an organization, we understood that no single technology can win that space, or say we need a co-creation with, or say we need a partnership. And then why do we partner? We thought that, okay, the community is the fastest area where things are, or new things are happening, or say innovations are happening. So we created or say a reference implementation of the possibility that we thought of, where both enterprise products of Red Hat to create the base and keep it for customers so that it doesn't fail off. However, those application sets, those are required for data engineer, business analyst, and data scientist. Those like say Spark SQL, Kafka Streams, or say Jupyter Hub, Superset, all these can be onboarded to our platform layer, and then thereby put that security governance and monitoring and orchestration can be kept from Red Hat side, by which the data stewards or say DevOps engineer can scale those applications or say format of applications to the layer that they want to create the model. We call it as Open Data Hub. It's available in Red Hat site. You can go and see how the build-up is. And then the discussion is that there is some model or best effort basis engagement model that can be kept where enterprise product and community product can scale. Yeah, Siddesh.
Hey, thanks, Prasenjit. So with that, let me come on to a convergence that we have lined up for the near future. And by near future, I mean this is a product that we are launching for September. It's going to be announced in August, and this is a sneak preview into what's going to come. We will have, this is called the Spectrum Fusion. It's an HCI appliance for OpenShift, a hyper-converged appliance where your compute, storage, and network is integrated with the management layer, which is an OpenShift management layer that manages the entire setup. It is very tightly integrated. It's a grounds up product that is jointly developed by Red Hat and IBM. That brings in a container appliance that's very tightly integrated. Now, typically a scenario where you are deploying a production environment on a container, on an OpenShift container environment, you got to worry about what do I need on compute? You got to worry about what do I need on networking. OCP has its own networking requirements that go in. How do I bring in the storage elements? How do I bring in the performance elements of storage? The HA elements that I require? How do I bring in the DR elements? The backup elements, and above all, after I've deployed all of this in silos, how do I manage all of this, right? Now that is what this appliance gives you. It gives you an ability to do a single step install of all your OCP workloads. All your container workloads can be deployed just simply onto this. It is an appliance that comes with up to 20 worker nodes. There are three nodes that go for the core administration and the storage file system. the remaining 17 nodes are something that goes support your OCP workloads. What we also have as a part of this appliance is an ability to do OCP virtualization. So if your environment has a few components which are yet to be modernized, you're yet to be containerized and still are in a VM format, you have the ability to run these VMs within the container under the OCP virtualization umbrella. This has an ability to do IBM cloud satellite. So you have the ability to run this as an edge device where you run any of the services out of the IBM cloud as a platform, as a service. You of course have Red Hat advanced cluster management capability, where you have multiple of these clusters that can be managed using the Red Hat advanced cluster management. So all in all, this is like a simple single step install for all your container environments and takes away all the pain that you have from an infrastructure integration perspective when you talk about container environments.
Siddesh, I will just start.
Yeah, sure, Prasenjit.
I think it starts with 3 node and then it can scale up to 20.
That's correct.
Yeah, please.
So this is in brief what we will launch in August and is going to be available for deliveries in September. So very keen to have discussions with you wherever you have container deployments. Both Prasenjit and I will be more than eager to join you on those discussions and be part of your app modernization journey. With that, let me thank all of you for being a wonderful audience, and Mohit, back to you.
Thank you. So it was really a detailed and informative session for our audience. So with this, we now open the floor to questions. But before we, I urge the audience, if you haven't sent any questions yet, now is the chance. You please send in your questions so that our speakers can answer them live. But before we take the audience questions, I actually have a question for you, which I think would be very much informative for our audience as well. So I just want to ask you, how do you see customers embracing hybrid multi-cloud and app modernization for production environment?
Hey, thank you, Mohit, for that question. I'm glad you asked that question. Actually, puts things into context. If I look at the scenario about a year and a half back to now, we have seen clients come a long way. And let me give you examples of there are multiple of these modern containerized apps, OpenShift apps, that have started getting deployed for production environments. And I'll give you some of the examples that we've come across with our enterprise clients. There is UPI, the UPI payment interface, which is one of the very large production workloads with very high performance requirements. There is trade finance, there is master data management, there is digital engagement hub, which is moving the containerized way. There is FASTag, which is your toll collection piece that many banks are deploying. So there are enough and more examples of clients embracing app modernization for production workloads. No longer is it only a DevOps scenario. No longer is it only a development scenario. It is something that calls for performance, because it's an environment that really needs performance, scale. You need high availability. You need DR, because now you are putting in all your business critical applications onto this. You need you basically need everything that I would need for my core applications. I now need for these app modernization environments, which is your performance, HA, DR, backup, all of it. So with that, Prasenjit, you would want to add?
Yeah, I will say that, yeah, it's many of the places, but I will just bolster it, like say critical use cases, like say stock exchange where failure cannot happen is one area, and then core insurance, government, all taxation and all these, definitely. But it is very obvious that people are looking it in terms of they want performance, they want scale, they want deployability in any architecture, and thereby the developer efficiency to bot in, and ease of manageability. I think these are the core things that people are looking in for selecting a container platform, and thereby Red Hat is becoming obvious with IBM as a scale factor.
Thank you. Thank you, Prasenjit. And thank you, Siddesh. So, while I don't see any audience questions right now, let's wait for a few moments. Again, I urge the audience, if you haven't sent your questions already, please utilize this time to do so. Please send in your questions. We have our speakers live on this webinar, so they can address the same. Meanwhile, while the audience is sending their questions, yes, yeah. So, anything else that you would like to add?
It's okay. I mean, Siddesh, what you? I think.
Oh, there is a question on check processing. Yes. So today for the so Srinivas, we have some of the large banks who still have the truncated MICR code and the NPCI database, and there is of course that's changing with the digital banking system coming in, but there are still a very significant amount of, so for this bank that I was giving you an example on, Srinivas, there are almost 2 lakh checks that get processed on a daily basis. And earlier it used to be 20 people that used to do it. Now it is done all using this AI model that is automated. The manual validation comes in only and only if it is below the threshold that, the accuracy threshold that you've defined for the system.
And that opens up, this is that how will we coexist with old versus new paradigm shifts? So definitely it gives them, that's why I said that it's the changes are happening. So we started with core Linux and going to the containerization layer. However, we don't left over those things and then brought in the new thing in cohesively as much as possible.
Right. And Prasenjit, that brings me to an interesting conversation. While there are questions that come up, I just wanted to point out to one live conversation for a manufacturing giant, automobile giant, who has presence on AWS, he has presence on Azure, and of course a private cloud on-premise as well. Now, as an organization, he wants to have a common policy for certain things. For example, his security aspects, he wants a common interface, a common security management system across a single pane of glass across all of these. Now, what the approach we've started working around some of these is the approach we take with IBM Cloud Satellite. Now, IBM Cloud Satellite, the infrastructure could be anywhere. It could be on the edge within the plant. It could be on AWS. It could be on Azure or any other cloud. It gives us an ability to run a platform as a service across all of these elements, which gives the customer an ability to create a single pane of glass on any of these. It's like running a platform on a service on multiple silos of infrastructure across the board, right? So that is one example of how we are really moving practically on the ground on something called as a single pane of glass management across the board.
Thank you. So I don't see any more audience questions. It seems that they want to have a more detailed conversation with the IBM team. So they'll probably get back to you separately or email. So we are at the end of this webinar. So that's all the time we have for today. I thank Siddesh and Prasenjit for sharing such insights, and I'm sure that there have been many takeaways for the audience as well. I also thank the audience for your interest and time in participating in this webinar. Thank you and have a great day.
Thank you. Thanks a lot.